later in the presentation, so we would ask that you hold all questions to that point. There is a chat or conversation feature as part of Teams, so please make use of that to write down any thoughts or write down any questions, and we'll try to answer all the questions either today or in a separate session or by email later on. So we hope that everyone enjoys it. And now I'd like to welcome Jeff Cowan, HCE's Chief Executive Officer and President, to say a few words of welcome. Jeff?
Well, good morning, everybody, and welcome to this inaugural event, the first in an education series that's going to be spotlighting local and international solutions and technologies that come together to create healthy, productive, and sustainable communities. As Dave mentioned, I'm Jeff Cowan, the President and CEO of Hamilton Community Enterprises, and I'd like to begin by thanking the Hamilton Chamber of Commerce, our presentation partner for this event, and the initiator of Hamilton's Waste Heat Recovery Project. Before I introduce our first speaker, I'd like to say a few brief words about Hamilton Community Enterprises, followed by a special thanks to those attending this morning. HCE was founded in the early 2000s, resulting from the deregulation that was occurring in Ontario's electricity sector. Wholly owned by the City of Hamilton, HCE has grown to become an integrated utility solutions provider, spanning the non-regulated energy and telecommunication sectors. An expert at developing community networks, HCE owns and operates district energy networks, distributed energy resources, including solar PV and combined heat and power systems. As well, we build and operate mission-critical internet and metro area fiber networks. HCE has become the expert at delivering the kilojoules, the kilowatts, and the kilobytes that power our communities. Finally, let me start with a special thanks to the many international guests attending this event and a great virtual welcome to Hamilton. I'd also like to acknowledge the elected officials and municipal officials who are present today, as well as recognizing many of the local promotion partners who helped drive awareness of today's session. These include the City of Hamilton, the Bay Area Climate Change Council, the Hamilton Industrial Environmental Association, Hamilton Oshawa Port Authority, Quest Canada, McMaster University, Sustainability Leadership, and the Atmospheric Fund. And now, a big welcome to our key content partner today, Peter Ondenberg, along with everybody at the Heat Academy, for bringing a global perspective into the best of breed ideas that communities are adopting to address the impacts of climate change. And in saying that, take it away, Peter.
Thanks a lot, Jeff, for that. So I'm Peter Ondenberg. I'm the founder of the Heat Academy. I have with me today, we can still, we have it on screen, Michael Jacobson joining us from Beijing, where you're based, Michael. You will join the session rather shortly. Just very briefly on myself, I've been in this sector of district energy for the past 20 years. Working during the past 10 years very much on spreading awareness and know-how about how do you develop these systems in different parts of the world. We're going to focus today very much on what has been done in the past and still is being done in the Nordic region in Europe. But as we all know, this technology of district energy is spreading across the globe as we speak. And we're going to refer to various cases around the globe during the 3 sessions we have in front of us. I will start now sharing my screen and just give you a bit brief background before we move forward into the actual session. I hope this becomes visible for everybody. Can you all see this slide?
Yes, Peter.
Very good, thanks. So great to be able to organize and run these sessions together with you in Hamilton. You will meet some of the other partners on my side shortly. We, as I mentioned, there are these projects moving forward across the globe when it comes to developing solutions to decarbonize heating. It could be heat networks, it could be building efficiency, it could be heat pumps, or a variation of all of them. Many of these projects have difficulties in moving from preparation and into delivery. It's difficult because of capex, of operational cost, and various risks in implementing these projects. And that's what we try to address in our activity area, particularly through the Heat Academy, where we are providing training to various people across the globe involved in this journey of decarbonizing heating and cooling. Let's see, and we have done collaborations for the past 10 years with energy operators, and primarily, I would say, cities and city councils across the globe. Are here on the screen. You see a few of them. We could add many more. And what we are basically a network organization. So we are present in many markets through a network of local partners, and all the partners have a very long experience in this sector. Thereby, we can share best practice and drive replication of best practice, thereby speeding up the process of decarbonizing heating and cooling. Currently, we are involved in a few projects. We are now very excited to be part of the training in these 3 sessions in Hamilton. We are currently involved in doing similar training activities and also advisory services in places like Thunder Bay, in New York, Netherlands and Switzerland, and you could mention others. And in most cases, it's all about collecting, which is the case in Hamilton, waste heat from industrial processes and make use of that to heat cities, thereby replacing gas. In this session today, you meet me, you will meet Michael in a few minutes, and also Adam, who is our local contact and partner on the Canadian market. So, as you might have seen already in the agenda that has been distributed, we have divided this introductory training sessions into 3 modules. The first module today, we're going to take you through the technology of heat networks, why they work and where they could work. And we are fully aware that you have already a heat network system in place in Hamilton. So obviously you have a very strong local experience in this, which we would be very interested to tap into as we move forward into our collaboration. But we're going to make this a recap of the basics of district energy and the solutions related to that. Next module, which will take place in January, we're going to have more of a deep dive session into the technologies and the strategies related to actually capturing waste heat from local industries. And then the third module in February, we're going to move into the more action-oriented. So what do we do in practice? How do we make this happen in real life? But today, it's the first part. And if I move into this section, I mean, there are plenty of drivers to decarbonize heating and cooling. I think globally, the big driver right now is obviously the climate emergency we are all faced with. But there are many more. I know it's not that urgent in North America, but in Europe, the cost of gas has become a very big driver to speed up this process. Taking a country like UK, you have seen gas prices move up 5 times in the past 6 months. And that's before the heating season starts. So that's a big urgency as well, obviously. But in the background, it's obviously the climate emergency driving these investments. Also, looking at the climate emergency, a lot of the climate gases, greenhouse gases, comes from the way we produce energy on the planet. And if we look at this graph, some 80% of the energy produced today is fossil fuels, comes from fossil fuels. Only a small portion, 10%, comes from renewables sources. And we can also see that every year we consume more and more energy, more and more fossil fuels. So even though we invest heavily in renewables, we can't really see how we can shift this trend. Another way of describing this is looking at this picture. we can see there has been this ratio of approximately 90-10, 80-20 for many years now of fossil fuels versus other energy sources. And the challenge now, following the discussions in Glasgow in recent weeks, is basically this: in the next 10 years, we are supposed to rapidly and radically reduce the amount of fossil fuels in our energy systems. And I think it becomes clear to everybody that we can't just do this with wind and solar. We need to do other things. And what are the other things? Well, and where should we start? And this brings us into the topic of today. And we're going to share all the slides, so you will have a chance to look at them in more detail. But the topic, one of the focus areas across the globe now is to address heating, at least on the northern hemisphere. In the southern, it's more of cooling that has to be addressed. This is a very low-hanging fruit to actually decarbonize heating systems. These are two graphs produced by McKinsey. You can find many more with the same conclusions, that heating is the low-hanging fruit that we need to address. And that's what you are doing in Hamilton as well as in many other places. And if we look at an area like Hamilton, this could be Glasgow as well, or Berlin, half of the fossil fuels consumed is for heating buildings. So half of all the fossil fuels that is brought in to fuel a local economy is used to heat buildings. And that represents almost 40%, say 1/3 of all CO2 emissions. So if we could do something with heating, we would have a very good chance of actually reducing our dependency on fossil fuels, but also to radically reduce CO2 emissions. And I fully understand that's the objective in Hamilton. A bit of a history. We're going to move to Sweden and back to the 60s. This is actually the home where I grew up. And when I was a kid, we carried logs up the stairs, and we had individual fireplaces in various rooms in the house. In the early 70s, my father decided, like many other Swedes, to invest in central heating, fueled by oil. And a lot of people did that in the early 70s, which was not a very good idea if you look back. Because in 73, we have the first oil shock, the crisis following the war in Yom Kippur in Israel, tripling or even more, increasing the cost of oil. In a country like Sweden, we didn't have any alternatives to oil. We couldn't really find any alternatives. In many other countries, Europe and also in Canada, I know, you had oil reserves, you had gas, and you could start producing what you needed yourself. We had to adopt a totally different strategy. The strategy consisted of, first of all, insulating houses to really reduce the demand for heat. Second step was to connect the houses to some sort of a shared heat source. In many places, in our case, it was a small biofueled boiler shared by, I think, a dozen of houses. And then over time, we have been able to replace these small, temporary, you could say, connections to really large heat networks covering big cities all across Sweden, but also in Denmark and Finland. And we have to keep in mind now, there was a crisis behind this. It wasn't that there was this wise political, analysis. We need to decarbonize well before anybody talked about climate change. There was an urgency, and I think this has to be kept in mind. It's very, very difficult to change a system that works unless there is some really strong driving force to do it. And I believe we do have that strong force now in terms of climate emergency, combined in Europe with another energy crisis coming up. Over time, and over the past 50 years, this network that started with a few buildings has grown into a huge network. The distance from the north to the south if you fly across it, is 60 kilometers. you connect and reach 500,000 inhabitants in this region of Sweden through the same network, and including the home where I grew up. And which is the topic of today, what you see in the picture to the left, that's one of the big fuel sources or heat sources for the network. It's a local chemical plant in the city of Helsingborg. And this is an evolution you've seen across Sweden, Finland, and to some extent Denmark, where you have a lot of heavy industries, steelworks, paper mill, pulp mills, etc., heating up villages and cities. Without the pipe network, the first initial pipe we connected to houses, then it would not have been possible. So the heart of the system really is the pipe network underground. Over time, we can shift fuel source, as you've seen here. In early days, the black part here is very much fossil fuels, but over time it has become possible to replace that as the system has grown in size. And today, in a city like this, less than 2% of the heating provided to the inhabitants in the city comes from fossil fuels. And the number of people connected here in the city, well, say 90% of the buildings in most cities are connected to this shared heat source. We'll come back to this slide later. So this happened all across Sweden. Overall market share for district heating and we need to keep in mind Sweden is a low density country, so it's not perfectly ideal for district energy. It's primarily in the cities where you can put it in place. But the overall market share, despite that, is 55%, with an overall fossil fuel content in the heat network of less than 2. A lot of heat comes from waste heat from industrial processes, which is very much in focus of the conversation today. If we look at the city where I'm sitting right now, some 90% of the buildings you see on this slide are connected to the same heat network, giving the city lots of flexibility in using different types of fuel sources from industries, but also from biomass. There is a very brand new biomass plant in the center of Stockholm, where they will actually implement the first big scale carbon capture and storage solution, making it a negative emission plant. As I said, when I started this background, the driving force initially was energy security. We didn't have a choice. Either we freeze or we find some other source or solution to heat our buildings. And we had to shift quickly because oil was in a scarce resource and it was very expensive. It turned out there were multiple other benefits in this. I highlight a few in yellow. Balance of trade, obviously, in a country like Sweden, where we imported 100% of the oil, we were able to save a lot of money, which could instead be invested in local communities, in developing these infrastructures in local communities, thereby creating jobs. It has proven to be a very affordable solution. It's hard in the beginning, yes. But over time, as you grow the network, it becomes a very competitive solution versus other alternatives. And Sweden operates since early 90s in a totally deregulated energy market. So you have no extra subsidies or support, political support for heat networks. But still, despite that, it has proven to be a very profitable solution, combining heat networks with various types of heat sources, including industrial waste heat. So all in all, it has proven to be a good development, which started, as I said before, from energy security. Today, we have the starting point more of the climate emergency, but the effects will be the similar also when we start from that angle. We're going to see lots of investments in local communities, job creation, and ability to develop new industries related to fossil-free heating. And obviously, globally, we see this development taking place big time in various parts of the world to address heating, to try to reduce the heat demand, first of all, by insulation, but then also connecting buildings to heat networks, and over time finding different ways of providing sustainable heat to these heat networks. taking a few examples, you can see in the graph to the left, the columns. The red part is the market share of district heating in various countries, and you see currently a very strong growth in Western Europe. Looking at the UK as alone, they have currently 2% market share. There is a very strong commitment to bring it to 20% market share in the next 20 years. So we see investments all across Europe now in these systems. And that brings us back to Hamilton and what you are about to do, expanding your existing heat network and hopefully also develop new systems parallel to that. And by that, I hand over to you, Michael, to take us further into the details of heat networks.
Thank you very much, Peter. I will try to share my screen also. And in the meantime, I would like to say thank you for having me, and it's great to see you all. I'm Michael Jacobson. Like Peter mentioned, I'm at the moment located in Beijing. I started out some 20 years ago in the district energy field, where I was responsible for the design and operation optimization of the Stockholm district heating system that Peter mentioned a little bit about before. For the past almost 15 years, I've been in Asia, mainly in China, but also working in surrounding countries like Mongolia, Kazakhstan, Uzbekistan on district heating, and also in the Southeast Asia and South Asia on district cooling. I would just check here, Peter, if you can see my screen properly.
Absolutely, clearly visible.
Maybe not now, right?
Not now.
Let's go ahead.
There we are.
So, hopefully it works. This is a photo from my office in Beijing, and obviously you can see the big difference, and this is what we thank district heating for. Nowadays, a clear blue sky in Beijing. With that said, it has been district heating operating in Beijing for many decades already. So what has happened is that for the recent years, district heating have started to play a new role when it comes to decarbonization, rather than from the beginning when it was constructed more in order to ensure energy security, as Peter mentioned, but also public welfare to heat the homes of the citizens of Beijing. Since 2014, there are some 1,000 boilers that has been decommissioned in Beijing. The production has been centralized with clean fuels, and the emissions have been reduced quite a lot, and the particles are more or less gone when it comes to the heating sector. So it has really meant a lot for the city, and nowadays it's really visible as well what it can actually bring. We understand well that you're familiar with the district heating concept, so we will see this a little bit as a recap on what really district heating is and remind ourselves what different role that district heating can play. So when we define district heating, we see it as a heating system with one or more heat production facilities for multiple buildings where we achieve scale advantages. And this is quite important to the concept of district heating, that we reach these scale advantages. And we get multiple different kind of benefits: financial, economical benefits, environmental benefits, energy efficiency benefits, and so on and so forth. We also often refer to district heating as multi-source, future-proof energy system. And these we have seen in many places that time changes, and we want to develop our system, utilize different fuels, new technologies. But when we have the district heating system in place, we have a backbone where we can utilize this for different purposes with different fuels, which make it much easier and create flexibility over time, both in regards to changing the fuels and so on, but also to expand and kind of adapt to the demand changes, both over time, but also in short time, like on daily basis and so on. We have seen the district heating systems develop over time. In the beginning, it was often the case that cities wanted to remove the local pollution out of the cities. So remove local boilers, just like in the case in Beijing here, and then move the plants out of the city and supply the heat through the heating networks. At that time, I mean, it started out actually in North America, in New York, more than 100 years ago, with the first district heating system, which we often refer to as the first generation district heating systems. These were typically categorizing by their steam-based systems, high temperature, low efficiency. Then it has evolved over time, typically what we refer to as the second generation district heating, where we have hot water up typically in the range of 130, 120 degrees water supplied from one or a few production facilities to different consumers. In the third generation district heating, that's when we typically went down below 100 degrees district heating water temperature, utilized more fuels, more production technologies in one network, what we then call pool operated networks, number of production facilities feeding into the same network. Recent years, it's almost 15 years ago now, time flies, the fourth generation district heating started to develop. Then we are coming down to temperature levels around 60, 65 degrees temperature. The reason for this is both to reduce heat losses, because we increased efficiency, we reduce heat losses, so that's one of the benefits, but also to utilize more excess heat, waste heat, and other low-grade energy sources. And this is something that we see is being developed more and more. Nowadays, the fifth generation is under development, which is often referred to one district energy system, which is both working as a heat source for heating, but also as a heat sink for cooling purposes. Now, this way of categorizing the district heating systems over time is not so that we easily can say that one generation is necessarily better fitted than another one, because what we learned over the years, and personally I worked on some 100 district energy systems by developing them or optimizing them, and one thing that we have learned is that all of them are unique. Every single system is unique. With that said, it's always something to learn from each and every case also. No matter where they are across the world, there are often things that we could learn from and get inspired from, and some good points that we could see whether it makes sense to implement in our system. We have to take departure from the consumer side. What are the demands and how will the demand develop over time? And that's why it's very important with heat planning. And the praxis of heat planning is quite different around the world. If we look at Northern Europe, in Denmark, there is clear rules on the municipalities to have up-to-date heat plans. If we just move over to Sweden, which is the neighboring country, there is no such practice that it has to be an up-to-date heat plan. There is a law saying that there should be a heat plan, but it does not necessarily have to be updated. If we look at Asia, it's very common. Obviously in China, there are the 5-year plans. It has been heat plans updated on annual basis, but also heavily on the 5-year basis. And now we can see that more countries are adopting the practice of heat planning and having that as a natural part of urban planning, so that the municipality always have an up-to-date heat plan. And it's very important to have this heat plan for many reasons. And even though that we are district heating nerds, we want to emphasize that it's not always the case that district heating is the best solution. It always is a good idea to look at it, we can say, critically, and make sound heat plans for the city or the area that we're looking at, but also to have sound feasibility studies, not having too optimistic feasibility studies or basis that we are basing our investments on. Moving on a little bit to what the district heating system contain of. So like Peter said, I mean, the big bulk is the pipe network with the production facilities. This shows a picture from the Stockholm network, and it is nowadays a very big network. And the interconnected network in the greater Stockholm is about 4,000 megawatt or something like that. But there are still small networks that are, we can say, not on physical islands as such, but the system is small islands or donuts, as we call them sometimes. And this is how the networks have been developed over time. They have been growing and they have been merged together, and then they have become one big interconnected pool operated district heating network. We have the pump stations. In this case, you can see the blue icons on the map here with the pump stations, which makes it possible to supply the heat further out in the network. And then we have the substations, that is the interface between the building installations and the pipe network. These are typically the main components of the district heating system. Not that complicated. Overall, it's not rocket science. This shows the system in another way, that we have the supply pipe supplying heat, and then it is the heat is transferred into the building, and the cold water on the return pipe is coming back to the boiler house and then heated again. It is a closed loop system where we, in many cases, are not losing a lot of water. I think in Stockholm, the water losses is about half of the total volume per year or something like that. While I should say said that there are projects where we have seen water losses that are great, but nowadays the technologies are really good. And we're talking about lifespans of pipes and main facilities like pump stations and so on that are the lifespan are several decades and up to 50 years. And often the calculation periods of projects are 30 years or something like that in terms of depreciation. Even though that it is not rocket science, it is an energy system, and the system has certain dynamics. So if we look at the heating demand, most of the heating is for comfort heating normally. We have different other consumers, like there could be industrial process purposes or so, and often domestic hot water. But we can see that the heating demand is very much related to the outdoor temperature anyway. With that said, if we look at the daily variations, it is quite big, and especially in the systems where we are providing domestic hot water, where we see the people wake up in the morning and start to shower, and we get a peak in the morning. And also in the evening, there is often a somewhat smaller evening peak, but still people are utilizing more hot water again, and then it goes down during the nighttime. And this also says something about the people's behavior, because just because we are at work or so, we are still using a lot of hot water. So it's not that we get a valley in the middle of the day just because people go to work or go to school and so on. It is a quite, compared to the nighttime, it is often a quite much higher load over the whole day. And then we see the difference between weekdays and weekends, and that's simply because of the user behavior. We move on a little bit. We also have, due to the distances, that it is water that we're pumping in the system. So it could take several hours for the water to transport from the production facility out to the consumers. And this is when we are looking into the networks, when we are making operation optimization, when we're planning our operation. It is good to be aware of this so that we can plan our production and our heat supply in advance. If it is getting colder in the following hours, we might want to increase the temperature and so on and so forth. So there are some dynamics to take into consideration. However, it is not that dramatic, but it's good to be aware of. And the topic that we will go much more into detail during next session in January, heat recovery. There are, like Peter said, the application of heat recovery has increased a lot recent years. We see obviously heat recovery from power plants. We see it from industrial processes, but also very popular today from the sewage water. So utilizing sewage water heat pumps, either distributed on a, let's say, block level or community level, or centralized close to the wastewater treatment plant. We also have heat recovery from data centers. I think if we refer back to Stockholm again, I think there are some 15 data centers in Stockholm where the heat is recovered into the district heating network. And this is something that we see also in Asia a lot. The heat from the data centers are being recovered. Then for Stockholm, who is going to become carbon neutral by 2025, if I remember correctly, there has been even further efforts in regards to heat recovery. So here we are also looking into heat recovery even from supermarkets and so on. And if we're looking at the consumer side, it is also more common now to supply heat to swimming pools and so on from the district heating network as well. So it's a much higher degree of integration nowadays than it is before. And also district heating plays a role in what we call multi-energy system. So district heating system can also help a lot when it comes to the electricity grid, both to produce electricity, but also in order for peak shaving, to utilize electricity when there is a valley and reduce the electricity consumption if it is a high demand on the electricity grid. So this interaction between the electricity grid and the heating network can provide great benefits from a more, should we say, the holistic energy perspective. Also, we mentioned about the carbon capture. There has been a number of pilot phases of carbon capture in Stockholm. And I think the prognosis says that there is a possibility to capture some 800,000 tons CO2 emissions annually by this technology just in Stockholm. So it's a quite remarkable potential for it. Another important, we say, main facility beside the pipes and the production facilities and the substations, it is the thermal energy storage, which can be both used to store heat on a seasonal basis or more on short-term basis. And this can be both for production optimizations or for reliability, for many different purposes. And it can also have a safety function where the storage tank is also used in as a, we can say, a pressure interlock between the production facility and the network. And this is maybe a little bit overcourse for this introduction, but it just to say that many of these facilities have many different features. With that, I will hand over to you, Peter.
Thanks a lot for that, Michael. And so what we try to do in this 30 minutes is to give you a very, very brief overview of the technologies. We're going to go deeper into this in upcoming sessions. And as I also mentioned, we're going to focus in the very last session very much more on, less on why it is good, but rather how do we get it in place in an affordable way. But I think I hand over to you, David, now.
Great, thanks, Peter. And Ankur, if you can share the screen, we'd like to tell you a little bit about Hamilton's district energy system, because as Peter mentioned, we're fortunate enough that Hamilton does have a district energy system. And I think at times we think it's probably one of Hamilton's best kept secrets is that it has a district energy system. And in one way, the fact that it's a best kept secret isn't a bad thing. I think what it speaks to is it speaks to the reliability of the service. It speaks to the reliability, or to how well it's operated, the fact that it's sustainable, the fact that it's always there. And those are all key things that are very important when you're talking about the supply of heat. So if you happen to live or work in one of the buildings that we supply district energy to, and you don't know that it's supplied by district energy, that's not a bad thing. But today we're going to tell you about it and make it a good thing. So maybe the first slide, Ankur. So just to come back and talk a little bit about what is a district energy system versus a conventional system. So when we look at conventional systems, or we talk about conventional buildings, what we would see is that each building would have its own boilers for heating and its own chillers for cooling. And each of these boilers and chillers have to be sized for the maximum peak load. Otherwise, the building will be cold on a very cold day or hot on a very hot day. So that means that the equipment must be sized large. And then for most of the time, it doesn't operate anywhere near the peak. And that leads it to being inefficient. It also means that there's poor utilization of it. So the building has this large boiler, but the large boiler isn't used to its capacity most of the time. And as well as having the boilers, one has to worry about redundancy, or having the equipment. One has to worry about redundancy and having spare capacity, and how is that dealt with. And what it means is that a lot of space is taken up in every building for heating equipment. When you come to a district energy thermal network, what they do is they share the heating and cooling equipment. And we'll show how it's all centralized, or it can be centralized or put in more than one place. One of the other things that happens is that buildings don't peak at the same time. So while each building has a peak, it is very unlikely that they'll all peak at the same time. So the network doesn't have to be built as the sum of all the peaks. It can be built at a lesser capacity. So therefore, it can save on equipment, meaning less capital investment. It can operate closer to its operating points and therefore be higher efficient and use less fuel. And what it does for the owners or the buildings is it makes more space for them to lease or to sell. And those advantages, one of the key things as we talk about low carbon and a net zero net zero world, all of those advantages of district energy only magnify when one is talking about net zero carbon or low carbon. So on to the next one. So Hamilton was very prescient or very visionary in the early 2000s when Hamilton Community Energy, HCE, was founded by the city of Hamilton to begin to be a district energy provider. And it had a lot of goals, or several goals at that time. It was to establish a thermal network. It was to reduce GHG emissions. Because if we look back in the early 2000s, that was the time when Ontario's grid, which we now take great pride in being very green, was fed by several large coal plants and wasn't green and had a large GHG emission factors. So what this was to make electricity using combined heat and power, harvest the heat, and then make electricity with clean burning natural gas and reduce GHGs by offsetting carbon emissions from the coal plants on the Ontario grid. Again, we talked about system efficiencies because the equipment operates better in its operating lines, increase infrastructure reliability so that one had greater dependability on the equipment, it was better maintained, to establish economies of scale. And that's been a theme that Michael and Peter have talked about, is in order to get equipment efficiencies, lots of times the equipment must be of larger size. And the last thing that it set out to do was provide resiliency to the downtown core. And that came with the backup of heating and cooling capacity, as well as the ability to generate electricity with a combined heat and power engine. Next slide. So if we look at what exactly the equipment that is in place in our district energy system is, our main thermal plant is at 79 Bay Street, right across kitty corner to the First Ontario Centre. It's actually built onto the Sir John A. Macdonald school buildings. A lot of people probably don't even think it's part of the school. But the corner at Bay and Cannon, or Bay and York, is our main plant, at which we have hot water boilers, a high efficiency combined heat and power engine that generates electricity and the heat is harvested from that. We have electric chillers that provide chilled water to the system. We have circulating pumps, and as Michael has pointed out, heating networks are pipes in which either hot water or chilled water move, and we have lots of distribution piping. And then at the buildings, what we have is heat exchangers. And these heat exchangers are usually fairly small, and you can see two of them in the bottom right picture. And they are fairly small, yet they're able to provide a lot of heat to a large building. Next slide. So if we go back to how it all started, it really started many years before HCE was formed in 2002. It actually started in 1976. And when it started with the development of the downtown and the building of Hamilton Place, the Convention Center, and the Ontario Government Building. Now, these three buildings were redeveloped and put together, and it was decided to establish a centralized heating plant and a centralized cooling plant that would supply centralized cooling and heating to all of those facilities. Now, one of the things that we're going to talk about, or may have been talked about, is one of the big advantages of heat networks is the ability to change fuel sources. And that ability of changing fuel sources is one of the advantages, or one of the things that we saw with Hamilton Place and the Convention Center. Is this complex was built in the days when electricity was cheap in Ontario, and living better through electricity was the statement. So these buildings were all built with electric heat. So we had electric boilers. Now, as the price of electricity rose and as through the decades, heating by electricity wasn't exactly the best and most economical method of heating. Clean, but expensive. So in 2002, because we had a centralized system, we were able to change over the heat to hot water, or it was already hot water, but we were able to change over the fuel source to natural gas. Clean burning natural gas, supplemented by our combined heat and power engine. We also expanded the system to include City Hall, First Ontario Centre, the Art Gallery, and the Library Market Complex. And those were all part of the early parts of the HCE network. In 2003, we added our neighbor, the Sir John A. Macdonald School. In 2004, we added residences, the Victoria Park Community Housing at Cannon and Oxford, and the two large residential buildings. So it's Queen, Cannon, and Oxford. Next slide. In 2010, we added the McNabb Transit Terminal. In 2012, the historic Lister Block was renovated, and it became heated and cooled by district energy. In 2016, we added Templar Flats. Here we are moving down King William Street beside Lister, or from Lister. So Templar Flats was added to the system as residential condos. The Electra office on 55 John, the iconic office, was added in 2016. And then in 2019, the new Hamilton Police Investigative Services Division facility was added to the system. Now, one of the things that's special, next slide, one of the things that's special about that is that when we first started doing expanding the district energy network in Hamilton, one of the things is that in a fairly old city, not old by European standards, but old by North American standards, there's a lot of things in the ground. And if you're going to add piping to the ground, it makes it very difficult. And in the early days, the city people that we were dealing with that control the streets and the right-of-ways said to us, you know, if you could go down 30 feet, you wouldn't have a problem. But where you want to be in the 5 to 6 foot range, there's all sorts of pipe and all sorts of wires. There's gas lines, there's water lines, there's sewer lines, there's networks, there's bell lines, there's all sorts of things. So one of the things that's very common in Europe, but wasn't ever used in North America, was the idea of using HDD, or horizontal directional drilling, to go down that 30 feet and to bore and then pull the pipe in. And that's what we did for a first in North America example of this technology for the Hamilton Police ISD building. And that allowed us not to tear the street up and incur all sorts of cost of construction and all sorts of cost of inconvenience as the street was taken out in order to put the piping in. But we were able to use pipe that we brought in from Germany. The spools on the left are the heating pipe that came from Brugg in Germany, and the spools on the right are the HDPE pipe that are locally produced, but are used for the cooling system. So we were able to make a world-class example in Hamilton. So it was an excellent thing. And now, next slide, we're talking about that the very start of our systems, the Hamilton Place, OGB, and Convention Center. We're now starting to talk about the redevelopment of those sites with a group called Hamilton Urban Precinct and Entertainment Group. And then included in that redevelopment is Cops Col, or FOC, or what was known as Cops Coliseum. So as part of this renewal, we believe that this gives us a chance to reimagine the downtown and move the system forward in a low carbon context, and allows us to regenerate the downtown system. But the downtown is not the only system that we operate. And just to put it in perspective, one of the things that Michael said is the downtown is a third generation system. It's hot water. It operates at around less than 100 degrees centigrade. But we also have a fourth generation system, a campus system at McMaster Innovation Park. And my colleague Ankur is going to talk about that.
Thanks, Dave. So what Dave talked about, all the developments going on in the downtown of Hamilton. While all that was going on, parallelly there was exciting stuff going on in the west end of Hamilton. So the picture that you see on the top, in 2010, we established a campus-type integrated community energy system at McMaster Innovation Park, which is a 500,000 square feet innovation complex in the west end of Hamilton, and basically utilizing all that we've learned in our downtown district energy and putting that into use at McMaster Innovation Park. So the building on the left that you see here is MIP Atrium, which had its own boilers and chillers back in 2009, and when CanMet Materials was constructed in 2010, the two buildings were joined by district energy piping, and the area the field that you see in between has about 500 feet, 81 boreholes, and geo exchange system, which basically connects the two buildings and supplies carbon neutral heating and cooling to them. So the idea to connect MIP was to integrate renewable energy sources into the mix, such as geothermal exchange, solar thermal. Now these solar thermal panels, they're owned by the customer, but what we've done is integrated them into our district energy system. So whenever there's excess thermal energy generated by these panels, it comes into our district energy system. Now, this system progressed from being two buildings to more than 4 now. And so the third and fourth building were added in 2013 and 2018. It's one of them was McMaster Automotive Resource Center, which is approximately 90,000 square feet office and lab space. And what that did was gave us the opportunity to connect via underground piping and establish a network for future proofing. So with that came along the next building, which is the Biomedical Engineering and Advanced Manufacturing, or BEAM. And one of the things that happened during this time was the electrical grid in the area was a little constrained, and the resiliency became very important to our clients, and that's what gave birth to an islanded system with a combined heat and power plant, or power generation, at 270 Longwood, which had the capability of seamlessly switching to grid power via automatic transfer switches, which are closed transition. So you, in the blink of an eye, you could switch from the grid to the CHP or vice versa, providing resiliency to the entire system. Now, all that's been done, and what we're looking at in the future and now is a 5th generation district energy system, or converting the 4th generation into a 5th generation, where principles of energy harvesting, energy sharing, and kind of getting around to the fact that one building's cooling could be another building's heating, and that can bring down the GHG emissions even further. So we've partnered with MCMaster University, and McMaster University's research project called Integrated Community Energy and Harvesting System is taking off, and we're the leading industry partner. And what that system focuses on is basically having different sources of thermal and chilling energy, and also demand side management, including electricity, and including all of that into a single loop that could connect an arena to a community pool. So basically, all the cooling that you need in an arena generates some heat that's low grade and can be utilized in a community pool. It's a very simple example, and that's our next step forward into basically venturing into integrated community energy. So, keeping with the theme of today of industrial waste heat capture, we do have a third system which focuses on industrial waste heat capture and process steam, which my colleague Michael is going to talk about. Over to you, Mike.
Thanks, Ankur. Yeah, so hi, everyone. So yeah, in 2016, HCE was awarded a CHIPSOC contract with the IESO, the Ontario Electrical Grid Operator, to provide grid resiliency as well as to utilize waste heat through district energy. And so working with the Hamilton-Oshawa Port Authority and their industrial tenants, a sugar refinery and a brewery, a site in the industrial Portlands was established near Pier 10. So in 2019, we commissioned a 2 megawatt cogen, which you can see pictured there. So providing power to the grid when dispatched, and recovering the waste heat from the exhaust through a heat recovery steam generator or waste heat boiler, to provide steam supplied to our industrial clients in the Hamilton Portlands. We also added 2 500 horsepower boilers in a modular approach to satisfy the 24/7 steam requirements of our customers. And so overall, this facility has given us an industrial presence at the Bayfront, and our experience here, along with utilizing the waste heat off the cogen, leads in nicely to the industrial waste heat initiative that we'll talk about shortly. Thanks.
You're muted, Dave.
So just to sum up, we've heard all sorts of things about global issues, global solutions, and now we've talked about local solutions. And one of the key themes through it has been energy security and equality. And these are major concerns not only in Hamilton, but around the world. We've talked about how we're now focusing not on so much on district energy, but on integrated community energy, because this integration is all very important. We need to talk about maximum utilization, getting the maximum out of every joule of energy that we use, and sharing that energy to make the most of it and to reduce our carbon footprint. So now we're going to talk about, or now we're going to move on to back to Europe and talk about how industrial waste heat is being harvested and being used for building heating in Sweden. And I welcome Baring Jesper to tell us more about that.
It will actually be me for the time being, David. I will start off. Jesper has some issues in accessing the session, but he's working on it. But I'll kick off this part of it, and I will share my screen. So, brief recap to my presentation before, you might recall. Let's see if that's Jesper joining. It wasn't, sorry. As I referred to before, this house where I grew up connected first of all to a small boiler using biofuels, and later to a large regional heat network. And it followed very much the process, and I think this is very important to have this as a background when we talk about industrial waste heat sources as well. First of all, to reduce the demand for heat in these buildings, that was critical. The more we can reduce the demand for heat, the better off we are in terms of the capex. We can reduce the size of the pipes. We can get less losses in the system when we operate it, thereby reducing the operational cost. And once we have done that, and there are various technologies which we're going to highlight in upcoming sessions, once we've been able to do that, we can take the next step, just like we did back in the 70s, to connect to kind of an intermediate solution. A small-scale heat network, Michael referred to it as a donut, where you could connect a number of small houses to a smaller network, probably using a temporary solution, could even be a gas boiler initially. And then over time, as you can grow the network, you can move into more complex energy sources, including industrial waste heat. And it very much follows this graph where you have only a house connected, then you're quite limited in the solutions you have. You can use a gas oil boiler, or you can use some sort of an individual heat pump for that particular house, but that's all you have as an option. When you create a donut, you increase the number of options. You can actually have a small scale gas CHP or even a bioheat solution. But in order to really capture the heat from an industrial process like a steel plant in Hamilton, there is a need to have a fairly sizable heat network to be able to absorb the heat and to justify this investment. And this is I mentioned this now that we move into the next step into this industrial waste heat. As you could see in my previous slide as well, we had a number of different heat sources providing heat to this network, including the chemical plant. And that chemical plant, and I hope, Jesper, you have been able to join us now, it provides actually a third of the heat for this entire system, regional system. So let me just jump out and see if you have been able to access the session now, Jesper.
Yes, I'm here.
That's brilliant, just in time. Perfect.
Yeah, thank you.
So you saw where I ended up, and I'll leave it to you. You've been one of the persons instrumental in implementing these solutions in practice in the city of Helsingborg. So thanks for joining us, Jesper.
Yeah, thank you. Thank you. Well, first of all, if we discuss Kemira as a solution, if that's what we particularly should discuss, we started that collaboration in '74. And they have been one of the very important sources for district heating in our scheme. And they provide roughly 350 to 400 gigawatt hours of recovered heat, so to say, from their chemistry industry, like 45 megawatt goes around a year, and they get paid a little bit more during winter time. And a little bit less during summertime. And it's a very, very fruitful collaboration, we can say. We, the energy company Öresundskraft, we don't have to invest in new generation plants, and they of course get revenue from this heat. And they also then have a safety, you can say, of remaining with their chemistry industry in Helsingborg, which gives them job opportunities and such. So it has been very fruitful from '74 and keeps ongoing still. A very good collaboration, we can say. And I saw you, Peter, also showed the scheme for Landskrona and Lund with the Evita system. And of course, a part of this heat also goes to the other cities. If they have a demand for heat, then it goes to Lund and Landskrona as well. I don't know, Peter, if I should mention some particular other stuff in this collaboration.
Yeah, I'd like you to share the screen again. And One question that often pops up, and we've seen it already in the chat today, is that how do you secure, I mean, if this industry needs to have a temporary close down for repairs, or even in a worse situation, they need to close the plant. How do you plan for that?
Yeah, of course, we have a lot of redundancy. So we always have redundancy if the biggest units fall out. So if our biggest unit is 140 megawatt, and we always have backup, even if that unit fails out. Then we have bio-oiled fired plants that can go in and supply with heat if necessary. And it doesn't happen so often, but it happens. And of course, we also have a huge accumulator tank. It's 40,000 cubic meters of water, and that can hold the capacity for like 2,000 megawatt hours. So that also is a very good solution to have if something falls out in the system. But we always have at least one unit that is for redundancy. And since we also are connected to the other cities, they also have redundancy in their scheme, so to say. So then they can provide to our city if that should be needed. So it's a situation where we both can avoid different investments in spare capacity.
And this very much brings us back to this picture I showed, the size matters, that it is important to get as soon as possible to a critical size in a system in order to be able to play around between different heat sources. Another topic, I think I saw that also in the chat, and it's often discussed, and that's the reaction from industry. So is it difficult to convince industrial partners to join up for these schemes? Have there been hesitation?
No, I think actually it's the other way around because we will always be here. We have the district heating. We have been here since '64. So we are on, so to say, very solid ground. But we don't want to connect some industry that only lasts for 3-4 years and then they get bankruptcy, so to say. So it's more like us being confident of they being there and not suddenly move their production to some Asia country or whatsoever. So I think that's a little bit our concern more than theirs. We are a very solid friend, or how to say it.
Yeah, and I think this is something that is what I would like to bring up as a topic now, is this industrial symbiosis that you create, and it has been mentioned previously in the different presentations today, that we actually create a win-win for the city and the inhabitants, but also for the industries. A company like Kemira, a chemical industry, would normally probably not be in this part of the world unless they were able to sell what used to be waste heat and dumped into the sea or into the air. Now they can make quite healthy revenues by selling waste heat to the city, giving them a competitive advantage versus their colleagues in other parts of the world. And we have seen in Scandinavia, this has been a very good way. Having the backbone of district heating pipes in the ground has been a very good way of attracting industries, actually. More recently, IT companies, big service centers for Facebook, etc., are quite interested in implementing their service centers in Denmark, in Sweden, in Finland, as they can sell the heat they generate from the process. But stay here, and I will bring us into another case. As Jesper mentioned, the case in Helsingborg, and this case in Helsingborg is very common. If you look at the cities around Sweden, in basically every city where there is a heavy industry, the city has connected its heat network to that heavy industry and creating this industrial symbiosis. What potentially helps, in even though district energy in Sweden is operating in a totally deregulated environment, so it has to compete with other heat sources in a free market. It helps having, in most cases, municipalities being the majority owner of the heat network locally. That creates this long-term stability that Jesper mentioned, creating also kind of a long-term planning in terms of heat demand, which Michael mentioned earlier. So that is, but we have also a much more recent case, which is one of the latest heat networks and potentially one of the larger scale or relatively large scale heat networks being developed in Sweden. And this is a city not far from Helsingborg, the other city we mentioned just now, where they have a steel plant. It's called Höganäs AB. And there has been a discussion going for many years about implementing a heat network. And by some 10 years ago, that happened, that they could start tapping waste heat from the local industry and thereby replacing gas boilers that were in place to heat buildings in the city before. And today, some 90%, up to 90% of the heat for this community of 25,000 inhabitants comes from this industrial waste heat from the local steel plant. The total investment for this project was 16 million euros. So what that is it's approximately $20 million, of which 2 million were granted. 2 million euros were a government subsidy. The interesting process behind this, because this is a latecomer in Sweden, where basically every city has a heat network since many years. There has been multiple studies taking place on how to develop this heat network, and I think it was probably the funding back in 2004 giving them the boost to actually do this, and now it is developed as a fully owned municipality-driven energy company. Success factors, and these can be interesting. Bringing back the conversation we had with Jesper just a minute ago, this has created a win-win opportunity between municipality and local industry. It creates this industrial symbiosis, as we have mentioned before. A key success factor here has been, and that's where it's really interesting to see this initiative you take in Hamilton with the session today, and probably other activities you have had before. A key factor in heat networks is to involve all key stakeholders from a very early stage to make sure that there is a secure and a strong buy-in for these solutions, to create the trust that needs to be there for the different partners to become involved in these heat networks. There is also need for strong leadership, obviously, and a good communication between political decision makers and local industry players. And we actually made a case study on this Höganäs case, interviewing quite a lot of people to understand how did it happen and what were the decisive factors. Obviously, it wasn't about playing golf, as I put as a last bullet point here, but it was actually being discussed when people in the community, decision makers, were playing golf. Why don't we do this, considering the challenges with climate and energy security and so forth? So this social relationships have been very critical, and I think this is a lesson learned in many other cities as well. We will have many more case stories on to be presented in the upcoming sessions, but I think we stop here and I hand back to you, David.
Thanks, Peter. Thank you, Jesper. Excellent information on the use of industrial waste heat. And what we'd like to move to next is to talk about the, as Jeff mentioned in the earlier introduction, was one of the things that started all this was a study that was funded by the Atmospheric Fund and led by the Hamilton Chamber of Commerce on the opportunities for using waste heat from the Portlands for heating uses outside the Portlands or for other heating uses. So that was a study that was undertaken. The report was published earlier this year. And just to summarize the report and to summarize the next steps in the report, I'll ask Ankur and Richard Allen to talk about, to give us a synopsis of the report.
Thanks, Dave. And thank you, Peter and Jesper, for a wonderful Swedish study that you guys talked about. A few things that you touched on are very important in our project as well, and there's definitely synergies between a global perspective and a local perspective. So Richard and I will take you through our study that was spearheaded by the Chamber of Commerce, and that began in 2019 and went through 2020, and now here we are at the end of 2021, where the study is done, and now a pre-feasibility study is done, and we are focusing towards a full-fledged detailed feasibility study. And like Peter said, many studies are required to make sure that there's proper buy-in, there's proper resiliency and redundancy, and risk is being averted. So I'll begin with a cartoon on the screen. So with the climate emergency being declared across many municipalities in Canada, there is talks about batteries and solar PV and green hydrogen and EVs, but the elephant in the room is still space heating. And we need to talk about that to make sure that it is being addressed and it's just not sitting there without being talked about. So that's why we will focus this entire presentation on decarbonizing heating. So we took a look at the global perspective. Now coming back specifically to Hamilton in the Greater Toronto area, what we see on the bar graph on the right of your screen here shows that Hamilton's industry is responsible for about 55% of the greenhouse gas emissions. Now it's rightly so, because Hamilton's industry has always been the bread and butter, bringing the economics back into the community, creating a lot of jobs, and just basically making Hamilton survive. And that's why this has been inherent to Hamilton. Now that being said, our two major steel producers have pledged to be carbon neutral by 2050, and everyone's on the decarbonization mandate. So what that will do is bring this 55% down quite a lot. And the graph on the right will start to mirror the graph on the left, which will show that the buildings, instead of being about 26% or 25% GHG intensive, will be more in the 40% mark. So that would be the new status quo. So in order to prevent that, what we are proposing is offsetting the wasted thermal energy from the industrial processes that's not being utilized elsewhere, and utilizing them to heat buildings, which will keep this bar where it is and therefore reduce a lot of GHG emissions. Now, in the previous presentations, it's been said that it's easier said than done, right? So we are talking about it, but in order to make sure that this happens, there needs to be a strategy which will involve all the key stakeholders, engage all the businesses, the community, the municipality, and us being the district energy provider. So the opportunity is to unlock the waste heat that's available, and in doing so, we'll improve the efficiency of the system by utilizing the energy to its maximum. We'll reduce the costs, and in doing so, reduce the greenhouse gas emissions, and therefore be on our carbon neutral goal by 2050. So this is what Hamilton's challenge and opportunity is. Now I'll take a little step back in time and help and hand it over to my friend Richard, who will tell where this project began and how we kind of jumped through COVID and everything. Oh, sorry. Over to you, Richard.
Great. Thank you very much, Anchor. My name is Richard Allen. I was engaged between 2019 and 2020 to co-manage the Industrial Waste Heat Recovery Project that was led by the Hamilton Chamber of Commerce with funding from the Atmospheric Fund. And it was a great success and has really provided a framework and foundation for where we are today. I think everyone understood that Hamilton has a wonderful innovation opportunity. It's unique to our community, and it's unique possibly to any communities that are rich in a manufacturing base. So what we're discovering in Hamilton is scalable to other communities, which makes it very interesting and so much tied to the stories that we're hearing from Sweden. We're eternally grateful to the Hamilton Chamber of Commerce, business-led organization, getting behind a project that has both social, economic, and environmental impacts is wonderful. So it speaks to the progressive nature of our local industry leaders and business leaders. We're also thankful to the Atmospheric Fund for its contribution of funding. Without that funding, we wouldn't be where we are today in the conversation. The goal of the study that was carried out under the leadership of the Chamber of Commerce was to identify at a very high level what those opportunities could be to unlock value from industrial waste heat in Hamilton. And the goal was to produce a report with recommendations that would provide a pathway for future work, just to open up an exploration of potential sources and potential sinks for that waste heat in Hamilton. The area that we focused on is a 10-kilometer corridor that is aligned with our waterfront, and it's called our Hamilton's Bayfront Industrial Area, and it's home to a high concentration of industries, including 2 steel manufacturers, as well as numerous other plants, including chemical refinery plants. Next, please. So, you know, we've talked a great deal about the importance of partnership and getting the players aligned and to be able to move the yardsticks. We use the term stakeholders and partners a lot into the success of where we are and where we're hoping to go. And Peter, you've underlined and underscored throughout your presentation the importance of community capacity to move the yardsticks on something like this. Our methodology during that project period between 2019 and 2020 was to frame the project as an industry-led initiative. We can't have industrial waste heat initiative without obviously the participation of major industries. So we have 6 industries that participated in our study, and it's only a cross section of what's available in terms of our industry footprint in Hamilton. We took a look at a wide sampling of heat sources and potential sinks, including potential ties to community-facing district energy. And David Inkley and others emphasized the point that this is just a sampling of the potential thermal energy within Hamilton. We just touched the surface, in other words. Another part of our methodology was to involve McMaster University, which has very deep research and practice expertise in the area of thermal energy and energy writ large. And we see Jim Cotton, for example, on the call today, and we're able to involve student researchers in the project. So I think that speaks to the capacity of what we have in terms of people and resources in Hamilton to support us. And we also tied it very strongly to a community energy and emissions plan that's in development right now. So it provides the urgency and foundation for the work that we're doing. And it's a critical link to the community and to our local government representatives that are commissioning and supporting this work. And of course, our partnerships with the Chamber, Hamilton Community Enterprises, so 6 manufacturers, and all the additional stakeholders that have made it possible. Back to you, Anchor.
Thanks, Richard. So I'll just quickly brush through what was done as a part of the sampling study that Richard mentioned, and what were some key takeaways from it. So we began with classifying the waste heat based on the energy attributes and their utilization. We classified them into three broad categories: high temperature, which is above 400 degrees Celsius, which could be best applied to manufacturing processes or power generation. The next one down would be medium temperature, which is in the 100 to 400 degrees Celsius range, and which is also well suited to manufacturing or basically still very high grade thermal energy that could be used within the industry. And the next one is low temperature waste heat, which is very suitable to fourth generation, third generation district energy systems, and that's in the lower than 100 degrees Celsius range. That's very appropriate for space heating and low temperature thermal networks, district energy, and one of the things that we like to stress upon is this low grade or lower grade thermal energy has no direct correlation to the industrial processes, and therefore it's basically available, and it's not going to conflict with any of the industrial processes that are there. So once we know what the inventory of our waste heat, we know our sources. The next step was to match the dots with the sinks. Now, one of the questions that came up in the chat was what happens if there isn't industrial waste heat available? Well, it's a very good question, because what we did and what we are doing as a part of this project is keeping in mind a many-to-many model, which would have many heat sources and many heat sinks. So we are playing on the diversity of the sources as well as the sinks. And that being said, there'll definitely be backup generation to make sure that none of the buildings on the system are cold. So that being said, how we're doing that is taking a sample of the area and what industries or developments are in the area that could either be a source or a sink. So starting with the left-hand side of the screen is the West Harbor area, which is the Pier 7 and 8 development. It's a mixed-use commercial and residential development that could be a very good heat sink, and it could have domestic hot water usage, commercial. Could have big box grocery stores, could have condos. So all of those could be a good heat sink. The existing tenants of the port, which are the Hamilton Oshawa Port Authority and their tenants which require process heating, right? And then there is industrial nodes within the area as well, like smaller industries which require process heating. And then finally, there could be possibly a link to the existing downtown district energy system that David touched upon in the previous presentation. And what that could do is create a network connecting the bayfront to the downtown. And what that would do is we could have opportunities to collect that waste heat and have more customers on the way, higher energy users such as the Hamilton Wentworth Detention Center, the Hamilton General Hospital, both high density energy users. So that's the theme of this project, to make sure that the community is involved and risk is averted. So just a little bit on the technical side, the enabling technologies that our project team looked at was energy transfer stations, which is very significant in a district energy system, heat pumps, energy storage, thermal grids, distributed energy resources, all the things, like everything doesn't have to be located at one spot. That's the thing that we need to understand. Moving along, I'll just quickly go through some key takeaways from our sampling study by the Chamber of Commerce. So it was noted that Hamilton's Bayfront corridor had was responsible for about 50% of GTHA's overall industrial greenhouse gas emissions. Now, this is just skimming the surface, and the sample recoverable waste heat, which is by the participating industries, was about 4 million gigajoules per year. That is enough to heat roughly 45,000 homes for a year. That's huge, right? And if you offset all of that waste to thermal energy, you are offsetting about 200,000 tons of CO2 equivalent per year. Now, all these things are being said, but as we talked about earlier, like the status quo is relatively inexpensive fuel costs and lower carbon pricing. Now, with the decarbonization mandate stronger than ever, that's changing, and projects like these will challenge business as usual energy practices and have multiple drivers, not just economic but social and environmental, right? And the benefits are also not just for one company. It's multifold. It's for the community. It's for the suppliers, the users, the intermediaries. Like all of them, all of us would benefit from a project and a system of this nature. So enough details about the sampling study that's been done. And if you'd like to know more about it, you can go to the link that's mentioned on the screen and take a look at the final report that was published earlier in 2021. So with this, I'll hand it over to Richard to explain where we are with this project and the feasibility study that we're looking at. Go ahead, Richard.
Thanks, Ankur. So people are asking what's next following the work of the chamber study. How do we intend to act on the report and its recommendations? Earlier this year, the Hamilton Chamber of Commerce and HCE Hamilton Community Enterprises teamed up to implement a follow-on initiative that we're calling Energy Harvesting Project. And the roles and responsibilities for this project are laid out in a formal MOU, which is exciting to see that level of commitment. The key goal of this Energy Harvesting Project is to take that deep dive into a community-facing district energy application for industrial waste heat in Hamilton. And we have our eyes on the potential long-term impacts of doing just that work. We see it as a way to modernize and expand district energy in Hamilton, and as everyone's, particularly David's, underscored, we have that footprint in Hamilton. Now is the opportunity to take it to the next level in terms of expansion and modernization. And it's also an opportunity to open up carbon cutting pathways to local district energy security in Hamilton. Next slide. So what we did in terms of putting this together, so my slide here, was to put a project plan together. And this is just a really brief summary of what that project plan for the feasibility study looks like. It shows a step-by-step process that HCE has put together with the Hamilton Chamber of Commerce. And all of the activities within the next little while are compartmentalized. Little sections of work, sequential deliverables, key decision points, all along a pathway to making a decision whether to go ahead with a full-bore, detailed implementation plan for a project. The strategy is to inform and involve stakeholders all the way along, and to Peter's point, right from the beginning, so we can hopefully join up and unlock those investments that are available to us. Today's webinar, for example, is a key component of sharing our vision with the community, which is part of the shaping exercise that we're into right now, building that awareness and enrolling the support that we'll need to move ahead. Next slide, please. So in terms of the architecture of the feasibility study, this slide lays out the different components of it. Just suffice to say that it's all about two components. One component is taking a look at the technical side of developing a system of utilizing industrial waste heat for district energy purposes, but that's only one part of the story. The other part of the story is obviously the commercial viability, as well as operational details, as well as governance. So over the next little while, that study will take a look at those very key components, and then it'll arrive at a decision point whether to take a deeper dive into an actual detailed engineering plan. Next slide, please. So here are the pieces of the work going ahead. Basically, what we're doing now is reaching out in Q2 to ideally start the feasibility study. We're looking at funding opportunities, 50% from the federal government. We're reaching out to the federal government for funding. We're seeking matched funding from diverse sources and stakeholders. So we're reaching out on an ongoing basis, particularly with industry and our municipal partners, as well as the commercial sector, to take a look at helping us build up a fund in order to enact this feasibility study. We are seeking early adopters, and we have many of those early adopters already identified through the 2 years of work that has been leading into it, and they're putting up their hands and saying, we'd love to continue to participate. And we're also reaching out to engage professional engineering and business consultants. And it's all with a goal to deliver a third-party report with recommendations to help determine the viability of pursuing detailed engineering work moving forward. Anchor. So what's the value of all of this work that we're doing? Well, first of all, the benefits are that it's building upon work that's already been done to date. As we've talked about, there's been over 2 years of work that's been put into place to pull this together. And probably the three core benefits of this feasibility study could be summed up in, first of all, we're going to unlock the additional value of the work that's been done to date in those existing relationships. We're going to continue to leverage the available funding, for example, from the federal government through grants to build back better within our community. So the timing is good for that. And most importantly, together, we're going to demonstrate joint action on climate change and resiliency within our community. Anchor. And so there's opportunities to engage. Today it's just the start, obviously, through the awareness building, through our webinar series with Peter and the HEAT Academy and others. There's other ways to participate. We're strong supporters of the Hamilton Energy and Emissions Plan that's being led by the city and multiple partners that were identified earlier today. We're keen supporters of that. In fact, they've identified district energy as being a key part of the plan moving forward to decarbonize heating and decarbonize industry within Hamilton. So we're moving in lockstep with a plan that's endorsed and supported by our community and municipality. And there's also opportunities to participate in the feasibility study itself through funding, through sitting around the table and co-planning the initiative and participating in opening up your doors to the research community that'll be helping to develop the plan moving forward. And the final image on our screen here today, it really sums up the story here. We've got in that corridor that's right near the waterfront, all of our industrial partners, the heat sources, and then all of those red dots within Lower City Hamilton are those dense, densely compact users of that industrial waste heat. The key will be obviously developing the network to be able to supply the heat to those users, and that's really what the feasibility study is all about. And back to you, Anchor, to and perhaps to you, David, to close it off.
Great. Thanks, Richard. And I think that we're very excited by the opportunities that have been uncovered by these studies. I think a lot of us with an industrial background and those of us who worked in the industrial bayfront of Hamilton all recognize the energies that are the waste energy that's lost there and goes to the sky, and how that could be better used. So we think there's great opportunity in this, and we think that while we haven't in North America, it's not common to leverage this waste energy. in Europe and especially in Sweden and other places in the globe, it is, and that's why we welcome the discussions with the Heat Academy to help us gain this knowledge and share this knowledge with our community. So, Peter, we had left some time. I think we're almost right on time to our agenda, which is amazing. And I think that we're now at the point to enter into some questions and answers before we wrap this up. So, Peter,
Yeah,
would you walk us through?
Yeah, absolutely. Thanks, Dave. And yeah, we are basically spot on time. Fantastic. Well done. But first question, I think Dave Carson, I checked you have left this session, I think, but John Ratburn, I see you in front of me. You actually answered the question from Dave in terms of how do you secure heat to a system? Could you comment on that, John?
Yeah, sure. So yeah, obviously we want to go for, I think your tree with the fruit on it was quite apt, but you want to look for your low-hanging fruit. And so from energy source perspective, industrial waste heat is one of those low-hanging fruits. So you want to prioritize and try and find those opportunities as much as possible, but it's not the only fruit on the tree. So good engineering practice will always be there. So it's just, there's a hierarchy of priorities, I would say, in terms of energy sources, and industrial waste heat is, right at the top of the list, but there's going to be a complete list of sources that can provide that type of resiliency and redundancy needed for safety.
And that's exactly what you could see, and Jesper outlined as well for the city of Helsingborg, that you need to have a backup of different heat sources, obviously. Moving forward, there is a plan to dig up the streets, and that's a good timing to put in pipes. Yes, it is very good timing, and that's actually a project underway in Thunder Bay in Canada, where they are looking at replacing the sewage system in the city, and in connection to that, put pipes in the ground. I'm not sure whether this is taking place, Dave, where you are planning, or where the intention was to put pipes?
Well, any time that a street is being dug up and any time that the infrastructure is being modified, Peter, you're exactly right. These present excellent opportunities to add pipes, and I think one of the things is digging the hole and filling it back in is probably the biggest proportion of the cost of infrastructure. So whether you put in one pipe or two pipes, being an old utilities guy, it was always you put in as many as you can and you put them in as big as you can, and whether the estimators will tell you that it costs more to do that, but in reality, there's only marginal upsides or marginal cost increases to do that. So it's always very important to look at what's available and to look at the opportunity that is presented and try to broker on that.
And it's a really safe bet to put pipes in the ground if somebody else is paying for digging up the streets. It's I would invest immediately myself if I could. It's completely risk-free, I would say. Richard Gilbert, you've raised your hand. You're on mute, yeah.
Am I unmuted now? Is that better?
Yeah, you are unmuted now.
Yeah. So I'm going back to the Swedish slides, and one of the there was a mention there of deep geothermal, and I've read elsewhere that it's being considered for Malmö, and I just wondered if you could say, if you know, why it's being considered and how far that consideration is along, and anything else about it.
I'm happy to say that, but Jesper, I see you in the picture. You're nearby, and perhaps you have some comments before I start.
Well, there's a lot of silence around that project, and actually, my own personal comment to that is the reason to why it's so silent is maybe it's not so successful at the moment. I know they have a lot of troubles, but that's only my own opinion. But I also know that they have started on another project parallel to this geothermal. So for me, it gives a little bit hint of that they maybe has to build a traditional plant or something like that. So, but we have to wait a little bit more and see.
Okay, thank you.
Nothing information leaks out.
But I think this deep geothermal is growing in importance in Europe. Definitely, there is a very strong interest. And then we talk really deep, and it's quite interesting in the industry. We see more and more people coming from the oil and gas sector, even entire companies moving in and investing heavily in district energy sector. And personally, I believe deep geothermal is going to be a very, very important solution in the future, but not the only one. As John pointed out, there will be multiple solutions. We have, and we've been kind of bragging about Sweden in this session, and that wasn't the intention, but we have big issues. We have a challenge with energy from waste. We import a lot of waste from other countries, which we burn and create heat and power. It's a great business because you make money on both sides of the factory, actually. But that's being challenged by for good reasons, and I think this is an area which we need to address at some point. Deep geothermal might be one of the solutions to actually replace that over time. I do believe still industrial waste heat will always be there, and we see huge projects coming up in Europe now. Just recently, last week, there was a decision to connect the port of Rotterdam to The Hague and Leiden. It's a 50-kilometer distance, a huge pipe network, and they will start putting the pipes in the ground already next year, a huge investment. So we're going to see lots of these investments coming up. Let's see, do we have other Hamilton home builders? Dave Carson, I don't know whether you're still in the session. It's a question, can Hamilton home builders become there? Dave, you're with us.
Yes, hello.
Hello, please.
The Swedish example showed a 60-kilometer span around one of the towns. That would bring in a lot of our residential accommodation, and I'm looking to see the home builders be part of your stakeholder group, because when you build a new subdivision, that's the time to put the pipes in. And I don't think it needs to be connected to the industrial source so much. There are other sources, as you've noted, hockey rinks and swimming pools and things like that. So can we draw them in as stakeholders in a big way?
David, we welcome a broad portion of stakeholders, and yes, no, like we're not excluding anyone. This is our part, this part of the project, or in our normal business. We'd like to talk to everyone. Sometimes the district energy projects are largely infrastructure based. Those are always the considerations, the cost of servicing. However, we welcome discussions with anyone. So anyone that has contacts with the Hamilton home builders or development people, we welcome those discussions, and we'd love to talk to them to see how some of our solutions could fit with what they're planning, and leading to how we decarbonize heating and meet the goals of net zero by 2050.
That's great to hear. Thank you.
And Michael Jacobson from Beijing, this brings us into the topic of heat planning, doesn't it? To make a good map of what are the demand and where do we have the sources. You like to comment on that, Michael?
Yeah, no, that's totally right. I think it was a great comment there from Dave, and I saw another question also there when it came to how large the district heating network could be and how far from the production site and so on. I mean, to give some references on that, if we looked at the Stockholm system from the very south to the very north, it's about 100 kilometer from one point to another in a straight line. That means, of course, the pipes are much further than that. We are building a lot of transmission pipelines that are in the range of 50, 60 kilometer heat recovery from remote power plant and so on. So the heat losses is not a very big issue, I would say. Then, of course, again, it's difficult depending on which kind of generation that we're talking about, because the big difference in temperature, supply and return temperature. If we go to second generation, maybe third generation, we can transport the water in a further distance compared to the fourth generation or fifth generation. But the distance in general is not a big issue. The key is density, I would say, is the heat density. I think there were also some other points that you mentioned, David and Ankur and Mike, earlier today. I think it was, good examples. You talked about the expansion and also that you are applying different generations depending on what makes sense in the different locations. I think that is, again, a good reminder that there is no one right solution. It could be different in the same integrated system. I think it's good to be reminded here. And this, again, all of these aspects comes back to the heat planning, because this is exactly the things that we're looking into when we do the heat plans. It's a combination of looking at what are the demands, what kind of temperature levels are required, what are the local resources, exactly those kind of things that we would look into. And then we will see which technology that would fit best. And actually the issue we often see in this part of the world is that it's too much technology focus. Technology is not an issue in general. There is very mature technology, robust solution there. So it's much more to look where we are standing, and then we should apply the technology that fit to the local conditions. That is something we really should remember. Thanks a lot, Michael. We have another Michael have raised your hand. Welcome. I'm afraid to say you're on mute. In Europe, they say it's the most common word. I mean, everybody knows it in English now.
Yeah, well, thank you very much. Michael here from Ottawa. I'm working with Richard Gilbert and others on looking at regional district energy potentials. I'm curious, in Sweden, one of the big features was in recovery of waste heat of lower temperatures was large-scale electric heat pumps from sewage effluent, seawater, lower temperature waste heat. What's the status of those? Are those still working well? And are these seen as an economical part of the system? Yeah, so I can answer a little bit about Stockholm there. So about 12% of the heat in Stockholm is based on wastewater heat recovery. So it's quite a fair share. The COP of those facilities is about 3.5, which we can say is not very high. On the other hand, there are old facilities and all the HFC refrigerants are phased out. So there is no, let's say, greenhouse gas refrigerants any longer, and they still operate on that kind of efficiency. And they're positioned as a, we can say, medium priority in the range of different production facilities. So in the base load, you have the waste incineration, like Peter mentioned, but then pretty soon the heat pump comes as the cheapest production option before biomass boilers and things like that. So it works very well. You have, when we look into Kazakhstan now, we can recover about 10%, we cover 10% of the annual heat load based on wastewater heat pumps. And actually in Canada, in Vancouver, you have a really impressive solution provider there, Shark, that is providing these kind of technologies. I think we have worked with them also in this part of the world. It works really well, I would say, and definitely worth to look into this kind of technology. And we should remember that again, when we look at the suitable production technologies, I mean, it's a relation between capital expenses and operational expenses. So in the base load, typically comes with high capital expenses, but low operational expenses. And then on the peak, it is the opposite. But typically, heat recovery heat pumps, it would be in between. It's relatively high capex, but also relatively low opex. So they fit typically as a medium load heat source.
Jesper, I think you have quite a lot of that solution in Helsingborg.
Yeah, we have heat pumps as well, and I noticed that we have the same numbers of the COP as well, between 3.2 and 3.5. But they suits very well. Of course, the electricity prices goes up and down, and then they varies about how much they run annually. But it's a good add-on opportunity to have in the scheme.
And I think this brings us also back to the point I made, and has also been made by others in the presentations here, the need for building efficiency to reduce the demand for heat in the buildings. That enables us to have lower temperatures in the heat network, and thereby reducing the OPEX for running a heat pump. So that is a critical part of implementing a heat network, to actually look at the buildings to see what can be done. We're going to highlight in one of the upcoming sessions new digital solutions, which are very, very interesting. 5 years ago, I would have said, change the windows and fabrics. Today, I would rather say the first thing to do is to implement these digital solutions, artificial intelligence with its sensors. You can easily save up to 20-25% by applying these technologies, and it's a lot of value compared to the investment you need to do. So by doing that, we can reduce the temperatures, the sizing of the pipe network, and thereby making it much more feasible to develop these systems. We have an easy question in the chat. It's about if you will get a copy of the webinar, and you will. We have recorded it. I don't know, Dave, how you intend to share it on a web page, or?
I think Peter will take your lead and send out a link to it, and I know that's what you do with all the Heat Academy things, or Heat Academy presentations. So I think we'll take the same lead. And perhaps, Peter, we're quickly coming to the end of time, so perhaps we could, I think we have just a couple summary slides, so I'd ask Anker to share them. And I'd like to thank you and thank Michael and thank Jesper and for everyone who's participated today. It's been an excellent 2 hours. The time's gone by very quickly. I hope everyone's knowledge has increased. And I guess, Anker, if you can share that, we'll just some parting thoughts. And so just one of the parting thoughts is about future proofing. And one of the things that's often said is that district energy is net zero carbon ready. And this is about how do we prepare for the future, and how do we go forward with our quest for low carbon. Now, it's often been said that one of the most important of life's lessons is learned in kindergarten, or we hope that it's learned in kindergarten, and that is of sharing. And that, we all talk about that. Well, heat networks are no different, and that's one of the big pluses of a heat network, is the ability to share energy. And one of the paradigms that has to be kind of shifted with everyone is that you don't cool a building, you take the heat out of it. And what we need to do is move from when we take that heat out, instead of wasting it, we need to be able to store it and use it for heating. And industry's no different. We have to capture that waste heat that goes into the atmosphere, and we have to share it. And we'll need to take advantage of the fact that heat networks can apply that kind of technology or those sources of heat in one place and use it throughout the network. So life is really better connected. So next slide. So that's our parting thought. Our next slide, just today we've heard all about the what, why, where, and how of heat networks. But there's more, and then we want to take a deeper dive into industrial waste heat recovery. That'll be coming up near the end of January, and we'll make sure that everyone's made aware of it, and hopefully others, please pass the word along. And then we'll follow up with a summary session in February to talk about what's necessary to get this going, what needs to drive it, the local capacity building. Peter just mentioned it about the digital solutions that can be applied, and really the future and how we can all work together to get on the track of low carbon and make our dreams, or make the reality of net zero carbon by 2050 possible. So thanks everyone for attending. We hope you have enjoyed it. We hope you've learned something, and we hope you join us at the next session. Thanks very much.
Thank you, everyone, for joining.
Thank you, everyone.
Thank you, everyone.
Thanks.
Thank you very much.